I'm Bill Viner, Chief Executive Officer of Pepper Viner Homes, and we're here this morning to tour you of the Pepper Viner BASF High Performance Home. With me this morning is Richard Barna. He's our Director of Green Building and High Performance, and he's actually going to give you a tour, talk to you about the collaboration with BASF, and give you detailed information about all the high performance energy things that are included in this home.
BASF approached Pepper Viner because of our standing in the green building world, and they wanted to talk about collaborating with us to build a home to prove that a production builder could build a high performance house and it could be a business practice that's successful. And so we tried a bunch of different technologies here. We actually picked a model plan from this project that's normally built in conventional manner and changed the plan so that it looks the same inside and out, but it's built differently. It's built with structural insulated panels instead of framing, spray foam insulation at the lid, concrete floors that are a special kind of concrete. There isn't a furnace in the house. We use a solar hydronic heating system which doubles as the domestic hot water system. A myriad of different approaches that were taken in the house, all adding up to a house that's 81% better than a code-built home as far as energy use. Typically, a home like this would cost $200 to $250 a month for all energy costs. This is estimated to cost about $50.
Let's go inside and actually see what Richard's talking about and get you a first-hand view. So Richard, as we start through the home, the obvious thing that we first see here is these concrete floors. So tell us a little bit about what went into this and why Pepper Viner and BASF decided to do this specific floor system.
One of the big things was indoor air quality, and we thought that if we could build with a total polished concrete floor throughout with no carpeting, that the indoor air quality would be much better. The finish that's put on is a permanent finish. It's a densified concrete. So the top is densified and sealed and the shine comes out. But the neat thing about this floor is it doesn't need to be refinished. Just needs to be buffed out occasionally, but it's a permanent finish, permanent hardened surface.
So Richard, you know, this really is kind of a living laboratory. I know we're doing a lot of testing and monitoring as we're going through here. But let's move on here and let's talk a little bit about some of the BASF products. And you know, you mentioned the local builder and the large chemical company. Talk a little bit more just briefly about that collaboration and really kind of what BASF brought to the table for us.
Well, as we started the process, we would pick different areas, starting with the concrete, and then working through, we wanted to switch to SIPS panels, which BASF makes all the parts of the SIPS panels.
And what are SIPS panels?
SIPS panels are structural insulated panels. They are a piece of expanded polystyrene foam surrounded by 2 sheets of OSB. There are no studs in it. These come in pieces up to 8 feet by 24 feet. They become the structure of the house. So in this particular house, all of the exterior walls are made of SIPS panels. So anyway, when we switched to SIPS panels, it creates some problems and some challenges for the trade partners. The electrician doesn't have open walls to run his wires in around the perimeter of the house. But these SIPS panels come with raceways at various places, at the location of the receptacles, the switches, and any other height that we want. There is a pathway through the SIPs to run the wires. So what we did is we brought experts from the SIPs manufacturer in to work with our subcontractors, including the carpenters who would install them ahead of time, and had training sessions and question and answers to figure out what challenges we would come up against, try and get them solved ahead of time through their expertise, so that when we came out here to build the house, it was a quick and easy process.
And the collaboration really wasn't just with the framers. We collaborated early on with a number of the other trade partners to make sure that the entire performance would be smooth, consistent, and they would really have more of an understanding of what we were doing in the home, and we would have more of an understanding of what products BASF was bringing to the table.
That's right. And we even brought in the architect and the structural engineer to these early training sessions, so that as the house was redesigned to these new standards, everybody was in the loop. It was and the other thing we did is we created checklists with the experts ahead of time so that we would be able to memorialize what took place, so that other builders would be able to look back and see What's that process to make the change from a traditional framing built home to a SIPS panel built home? From a traditional carpet and tile floor to a polished concrete floor? What are the things you have to be careful of? What are the things that you have to do a little differently along the way? And it's better to learn and memorialize than it is to just go trial and error.
So, Richard, let's step in this other room. I know you've talked about the SIPS panels, but let's give them more information about the foam itself, not only the foam in the walls, but the foam in the ceilings. And if we step in here, we've actually opened up an area that we can give them a little bit of information about the ceiling insulation.
From the top plate up across the roof deck, we spray intertight open cell foam up against the underneath side of the roof deck. It's about 5.5 inches to probably 8 or 9 inches in the deepest parts, so that there is a continuous air barrier and insulation barrier all the way throughout the house.
Yeah, it really makes a difference, not only from an energy efficient standpoint, but the whole home is so quiet and airtight. You talk often about how you've come in certain days in the middle of the summer in this home, and essentially it was as cool as the night you left it.
Let's say power goes out in a thunderstorm in the summertime, and your air conditioning goes off for a length of time in a typical home. The temperature goes up really quickly. I mean, within an hour or 2 hours, you start feeling really discomfort in the Tucson summer. This house, in one particular instance, it was 108, 109 degrees, and I had the temperature set in the house at 78. When I left the house at 11 o'clock one day, it was at 78, I pushed the thermostat up to 85. Came back 25 or 26 hours later, and the temperature in the house had only gone up 1 degree. That's a big difference from a typical home. We wanted to use some recycled content material, so all of the tile that we chose for the house is made of 40 to 50% recycled material. And it's beautiful tile, something that, you know, a designer can really have fun with. We searched and found a brand of cabinets that's certified to have no off-gassing of the bad formaldehyde, which is a carcinogenic. We introduced the Bosch dishwasher, which is super energy efficient, one of the most energy efficient on the market.
What about the other Energy Star or energy rated appliances?
Everything that could be Energy Star rated in this home is. In lighting, incandescent bulbs are very, very inefficient and bring a lot of heat into the house when they run. We don't have any incandescent bulbs in the house. We have a combination of compact fluorescent screw-in bulbs in all of the fixtures, like the recessed cans, and then the lights, the pendant lights, the dining room light, the bathroom lights throughout the house are pin-type fluorescents. And the reason we did that, there's an Energy Star advanced lighting package criteria. And you have to have a certain percentage of lights that cannot be changed out. They can't be, like somebody could come in and take those CFLs out and screw in a regular incandescent bulb. By putting the pin type in, they can never be changed. Those lights will always be energy efficient.
What about the windows? I know we did some special things with the glazings as well as the frames.
These windows are made by Milgard. They're vinyl frames, the same frames that we use through our project here at Civano.
And why vinyl frames?
Well, vinyl frames do not transmit the heat from the outside to the inside like an aluminum frame would do. Vinyl just does not conduct heat. And we've been using low-E glass as a standard on the project. This particular glass is the 3rd generation of low-E. It just takes it a little bit better, brings us down to a 0.27 solar heat gain, which is a very good number. They're good windows. We found that is not a bad place to put a little bit of extra money, is in the glazing of the windows.